access it? Cool. Yeah, so just refresh your browser because I just made it published right now. Um, yes, it's in full week 6 folder. It should look like this. Where is it now? This one. Okay. So it has all the instructions. You know me, like I love creating activities like this for remote learning because even those who are absent can follow along and not miss a thing. I just made a super major mistake. I meant to put geogebra.org/geometry, but I put graphing. So if you click on that one, that's okay. And then we're just gonna change the link when it opens. I'll try to like open them side by side. So before you start, you see that word after the forward slash. Okay, so change the graphing to geometry. There you go. Because the other one doesn't have segment tool, um it doesn't have measure tools and stuff like that. Okay. It's more for algebra than for geometry. All right. Okay, so let me see if I can still make this smaller so I can show the tools in my GeoGebra. Okay, I think this will do, right? So you can maximize your GeoGebra screen, maybe, and then yeah, it's in Schoology. Oh, sorry. Yeah, it's it's in two places. I have a separate one in OneNote. I also put that link in there, and then the one that you have to turn in today is this one. Yep. So you have to access it in Schoology. Yep. Okay. So let's get started. Go ahead and show your axes. Do you remember how to show your axes? Let me delete my. Okay, here. So you click on that. Um, it's inside week number 6 folder. Maybe if I send this to you in the chat, I think this would work, right? Okay. Yeah, just make your own copy of that. So you can submit it at the end of the period. Okay, so show your axes like that. Maybe major grid lines only. That will be enough. There you go. All right. So the very first thing that we will do is to construct a parallelogram. Yep. Construct a parallelogram. Yeah, okay, so I get it. Because I put the wrong link. So Abraham, you see this one at the end? Originally it was graphing. Now you're gonna change it to geometry. Yep. Change it to geometry. Okay. So the very first thing that we will do is we are going to plot some points. Okay. And then after that, we are going to analyze why a parallelogram is defined as such. You see this one? All right. Okay, so let's plot our points starting with 4, 6. So you toggle between these two options. If you want to plot a point, you got to go to the calculator mode. So 4, comma 6. Does it work without? Oh, I have to enter the parentheses. My bad. Okay, so 4, comma 6. And your point pops up right here. Should I? There you go. See that one? Okay, now do the same thing. Abraham, did you make it work now? Did you change it to geometry? The next one is 16, comma 6. I forgot my parentheses again. How do I do that? You you go to this you go to the calculator mode or algebra mode so you can plot the points. When you plot the point, you gotta put a parentheses, and then I'm now plotting my third point, which is 0, 0. Okay, does that work? Yep. Let me know if you have questions. You got it? Okay, and then the last point is 12, 0. There. Got it? Okay. So now you have to connect the points. So use the geometry mode and click on segment. Am I going too fast? Just right? Am I losing you? Okay. Let me know if you're confused. So what am I going to do next? I'm going to connect the, can you do that again? Which one? Yes, if you know what to do, keep going. If you know what to do, keep going. Which one, honey? Which one did you want me to show you again? Where you go to geometry. Okay, this one? Did you do this part when you change it to geometry in the address bar? Okay, then you have to click on that one. Originally it was graphing. Yes, so now you have to change graphing to geometry. And if you find me too slow, guys, just keep going. Keep going. I don't want to lose anybody, so just go ahead. Yep, the instructions I think are very detailed, right? And just clarify if you need something. You got it? Let me know. Were you able to change it? Or just start on a new one. Here, just click on that link. Oh, you got it. Okay, good. Cool. Alright, so now if you want to plot the points, you're going to click on this one. You see this? It says algebra tool, and then you put your points by typing them in parentheses. You don't have to put A equals. As long as you put the numbers, it will automatically name the points. Okay. And then after that, you go to geometry tool and connect your segments like this. Okay, let me know if you have questions. Okay, so if I could have your attention super quick, in number 2, I already wrote down the definition of a parallelogram, right? But what I would like you to do now is find some evidences, this evidence have a plural form? Okay, so support your definition with evidence from the picture. So for example, it says a parallelogram is a quadrilateral with two pairs of opposite sides parallel. So how would you prove or show or support our claim that the opposite sides are parallel? So you have to use your image, okay, you have to use your sketch to do that. So you have to add more to this by supporting your claim or our definition that the opposite sides are parallel. Okay, so think about that. Okay, and I'm gonna give you about until maybe 1:30ish to work on as many questions as you can. Yes, and then we'll discuss your answers later on. Okay, so work on as many items on that Google Doc in the next maybe 5 to 10 minutes. Okay, all right. Is it fine if we use? Oh yeah, definitely. Or you could just put the letter. That's fine. Yes. Okay, I paused the sharing. So yeah, so just stay on that Google Docs. If you have questions, let me know. Just type in the chat and I'll try to help you out. Hmm. You can't seem to find the segment tool. Yeah, hi Adeline. Um did you change your okay, do you see like the top of my screen right here? There you go. Like I made a mistake. I put graphing instead of geometry. So just delete that graphing word and change it to geometry. But then you have to enter your points again. I'm really sorry about that. My bad. Yeah. Mhm. Thanks too, honey. So do as many as you can. Move on. Hopefully you can write down as many claims as you can and then we'll try to discuss them later on. Let me know if you have questions. And would you like to explain a little bit about your results? Okay, and we should be getting the same values. That's why I fixed the corners, okay? So you should be getting the same values. Keep going, honey. So what's the other way to describe that? What's that S word that means equals 180? Yep. Half half of many other sides. Yes. So if there are four sides, there's two diagonals. But don't think that it's true for all polygons, okay? So the number of diagonals depends on the number of sides of the polygon. Keep going, honey. Mm-hmm. It was done, I think, for everybody. Yeah, I forgot to erase it. Okay, now for number 8, diagonals of the parallelogram bisect each other. Were you able to show that on your sketch pad or geometrist GeoGebra? Can you show your thingy, your sketch, honey, if you don't mind? The GeoGebra? Oh, okay. That's I know, and I cannot find it in any of your tabs right there. What should be the okay, anyway. Alright, that's fine. Thank you though for sharing. I appreciate that. Okay, would anybody like to share his or her geometrist um or GeoGebra sketch? Anybody? Anyone? Okay, I just want to point out that, okay, I'm going to share my screen again. I just want to point out that when you screen, where's my, this the one? No, it has to be in another, no, forgot, oh, here, there you go. So when you show the second to the last one, make sure that you connect the two diagonals. And when we say diagonals, we connect the two non-consecutive vertices, those that are opposite each other, right? And you have to plot a point at the middle. Okay, you have to put a dot in the middle so you can show the measures. Once you have that, you're going to click on more, and then you have to measure the length from AE to ED, and then from CE to EB. There you go. Okay, so you have to show us that, including the measures of the sides. You remember how you got the measures of the sides there, right? Okay, so you have to show all that in your screenshot, and you have to click on the angles one by one as well to show the measures of all the corners, right? Like the angle, angle. Oh, what did I do? 1, 2, 3, and so on. Okay. And if you have those two, James said opposite angles are congruent, so you're expecting the same one for angle C and 123 something for angle D as well. Okay, so that's the one that you guys are going to screenshot and paste at the bottom um, of your Google Docs. Okay, you can click enter from here and then paste your screenshot. Alright, so diagonals bisect each other, and how did you answer number 9? Compare any two triangles that form a vertical angle. Let me make that bigger. So what do I mean by that? If you look at, oh, what did I do? Why do I have a point F there? I need to undo it. Okay, so if you guys look at my triangle over here, these two triangles are actually congruent. Triangle 1 and 2 are congruent. Now, can somebody explain why they're congruent? What tells us they're congruent? SSS. Yes, that's correct. So, side and then another side, right? And then 1, 2, 3. 1, 2, 3. Is that the only way to explain their congruent? Is that the only way to explain their congruent? ASA. Ooh. Wait. Using your GeoGebra, you can verify if you know if these two are congruent to each other. Yes? But are we expecting them to be congruent? What do you guys think? Alternating two angles, right? Okay, so SSS, what else do we have? ASA, what else do we have? One more. One more. Actually, two more. Yeah, two more. What else? SAS, that's great. If you want to do SAS, you're going to use the vertical angles right here. You see these two vertical angles? Right? They're congruent to each other. And then if you do the alternate interior angles, you can also do side angle. Okay, so that means the top and the bottom triangles are congruent to each other, and the same is true for triangle 3 and triangle 4. But it doesn't mean 1 and 4 are congruent, okay? Because as you can see, the sides are different. Now, when you were in elementary, listen to me, look at the screen. When you were in elementary, a parallelogram is a parallelogram only, like the slanted rectangle that you see on your screen right now. But we're going to undo that. So can you name other parallelograms? Can you give me other shapes that are also parallelograms? Rectangle, very good. What else? Square, good job. What else? What else? A parallelogram is a quadrilateral. So meaning if it's a quadrilateral, it has to have 4 sides. Very good, Hector. That's the last one I'm looking for. Rhombus. Perfect. So a trapezoid is a quadrilateral, but it's not a parallelogram. So let me explain why. If you have a rhombus, it only has one pair. I'm sorry, my drawing sucks, but you see, these are the only two things that are parallel in a trapezoid. You get what I mean? But remember your definition? How did you define a parallelogram again? It has two pairs of parallel sides. You just said their opposite sides are congruent and parallel. So if you have a trapezoid and also, what do you call this shape? What does it look like? I tried my best. Don't judge. Okay, so what do you call this shape? This one. What do you call this shape? That's also a quadrilateral, but it's not a parallelogram. What is it? Looks like a diamond, but we call it a kite. Yep. So we're gonna talk more about kites, about trapezoids next time. But today, our focus are those that are parallelograms, because whatever you discovered now for a parallelogram will also be true for a rectangle, for a square, and for a rhombus. But those three will have other special properties. Let's say, for example, in a parallelogram, this angle is obtuse while this is acute, right? Well, same is true in a rhombus, but in a rectangle and square, what's going to happen to those angles? Will they be, they're all going to be equal, and they're all going to be what? If they're all equal, what's the measure of each corner? It's a right angle. Okay, so in other words, this will be our baseline data for all parallelograms, and then we're gonna keep adding as we discuss more shapes. Okay, that's interesting, right? And then later on, we will make a quadrilateral tree to show all of the possible scenarios. So go ahead and finish your Google Docs. Please submit that when you are done. And yes, it should be turned in as soon as possible. Not next week, but latest will be tomorrow. Okay, and I'm gonna ask you to go to OneNote after. It should be in your week number 6 already. It's called quadrilaterals right here. And what I would like you to do is you're going to type in every box. There you go. And you can also insert Google images to fill these up. So please take note that we are defining here a quadrilateral, not a parallelogram. Okay? So we are defining a quadrilateral. Alright? So go ahead and do that for me. Let's make it more visually appealing. Make it bigger. Too big. Okay. Alright, so we are trying to define quadrilateral in here. So go ahead and type in each box. What is a quadrilateral? How do you define it? How do you describe it? Yeah. So a quadrilateral is a polygon that has what? So a polygon, you can complete that sentence for me. I'll just wait in the chat what you guys are gonna share. So a quadrilateral is a polygon that has what? Were you able to type on it? Okay, that has 4 sides. That's great. 4 sides or 4 angles, same thing. Yep. Now let's write down some characteristics. How many diagonals does it have? You can write about that. Next will be the sum of its interior angles is, write about that. The sum of its exterior angles, one at each vertex, is, I spelled something wrong. What did I? At one at each vertex is, there you go. Okay. And we also discovered something today. The diagonals, right? Are the diagonals concurrent? Do they intersect? You see that concurrency again. The diagonals are concurrent where? In or out? In the interior of a, okay, the interior, period. Alright. Okay. So those are some of the characteristics. Is there anything else that you discovered? You can write it down. Now when you go to the examples portion, you can actually insert and find some online images. Only 4 angles, that's great. Okay, because it's equal to the number of sides, right? So you can see that the number of angles is equal to the number of sides. So if you want to Google a rectangle, you could do that, right? I think. Does it come up? Do I click enter after? There, so you can click on examples of rectangles, find the most appropriate one. Okay, what other stuff? You also have trapezoid. There you go. So you can Google that and paste that. I think you have to click it and then insert it. Do you know that there is also what we call a trapezium? Maybe I said it wrong, but okay. So a trapezium is not like an isosceles trapezoid, you know? An isosceles trapezoid normally has its 2 legs congruent. This one is a trapezium because no 2 sides are congruent. Yep. Okay, those are some samples. You can also put rhombus. I wonder what it will show if I put a kite. That's a rhombus. Yeah. I wonder what it will show if it's a kite. Maybe it will show like an actual kite. Yes, so maybe I should type kite quadrilateral. Kite geometry. Yeah, did it show? If it's kite geometry. Oh, there you go. Okay. So those are some examples. Okay, and then you have to find non-examples, such as, well, you said earlier, pentagon, right? Okay, so you can find those there. Did you watch the landing of Perseverance on Mars yesterday? Who among you here are planning to take up space-related courses when you go to college? Do you know that there's a course called nanotechnology at San Pedro Steam Magnet? Mr. Ferguson, the new teacher, is teaching it. I think that's the intro to robotics. Don't you have him? Like you're doing the 3D printing, right? Yeah? Uh-huh. Yeah, I remember you showed us that. Okay. Yep. Um is he doing robotics too, or it's just intro for now? Yeah, it's it's his first year teaching, so he has to like um yeah, okay, so he starts with programming. That's cool. Mhm. Yeah, so consider being a math teacher too, you guys. When you're a math teacher, you can do a lot of, you're not just a teacher, you know? Mm, like Mr. Ferguson can do a lot of stuff other than, teaching in the classroom. Um, he can also apply for other jobs that need math. Yeah. hmm But for me, I always wanted to be a teacher. So, all right. So we're good with that. Are we good? Okay. So if you're done with your what do you call this? Um, uh-huh. With your OneNote, let's go to proving parallelograms. Proving parallelograms. So you don't have to do this. It's the same Google Docs that we did. I just wanted, for them to all be on one place. Now, this is a summary of some of the things that we discovered using GeoGebra today. A quadrilateral is a parallelogram if, okay, so if you want to show that a quadrilateral is indeed a parallelogram, then you have to make sure both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One pair of opposite sides are congruent and parallel. So if it's just one pair, you have to show two conditions. They have to be congruent and parallel. Alright, and of course diagonals bisect each other, meaning they cut each other at its midpoint. Right? Okay, that's cool. Now I'm gonna ask you to do I'm gonna ask you to do one thing. I found like a lot of good practice questions right here. So remember that website? Okay, go to this website right here, and we're going to do some examples showing computations on what we just did today. And you can check the answers at the bottom. So make sure you are in the infinite geometry section. And if you guys want to do, some math over the summer, you see you have a lot of topics right here. And the good thing about that is you can actually check your answers at the bottom. Okay, so I was looking at some of these. There you go. I want to do the properties of parallelograms. I did this, but it's too easy. Well, let's look at it. Classifying quadrilaterals. Let's try. Okay. So you just have to kind of give like a specific name for it. Yeah. So can we skip that? It doesn't have any computation at all. So okay. But I wanna point out to these ones at the bottom. Because when it says state all possible names for each figure, you don't limit yourself to just one answer. So before you look at the answers at the bottom, can you think of some? So what name can you give number 13? It's a quadrilateral, that's one. It's a square. It's a parallelogram. You're missing one more. because a square can also be called a, okay, you can also call it a rectangle. See? You can also call it a rectangle because remember, um, the definition of rectangle is it has, 4 right angles. But a square also has 4 right angles. At the same time, it just has that extra condition that all the sides are equal. Yeah? Okay. So by definition, a rhombus has 4 congruent sides. So that means if you have a square, it is also called a rhombus. Yeah, I'm trying to like find um yeah, I wanted to like come up with a quadrilateral tree. Or maybe we could Google that next time. I'm trying to like find like a very good one that summarizes all those properties. I'll share one with you once I see like a good one. Okay. So number 14, look at number 14 right here. It's all of them are quadrilaterals, definitely, right? Okay, this one is just showing you that it has 2 parallel sides, so it's a parallelogram. If it doesn't say anything about the angles, you can't go past a parallelogram. Uh-huh. Okay, so it's a quadrilateral, it's a parallelogram, right? And it's a rhombus because it's all its sides are congruent to each other. Okay, so do you get this part of naming quadrilaterals? Can we skip this? I want to go to the part that has computations, really. Yeah. Okay, but you can always go back to this, if you want to practice. Okay, so I'm sharing this resource with you. Let's go here. Properties of parallelograms. Here we go. You ready? Okay, let's do a fast answer. Don't look at the answers yet. Don't scroll down yet. So let's see how much you guys remember. Okay, number 1. What should be your answer? 45? Try again. Number 1. I'm in number 1. Are we looking at the same thing? Properties of parallelograms. Are we looking at the same thing? 135. Good job, Abraham. Because we just said opposite angles are congruent. Nice, Ricky. Ricky, how do you put the degree sign in the chat? Anyway, okay. Control Alt 8. Oh, wait, what's on 8? Oh, Control Alt. Oh, I didn't know that. Oh, Shift Alt 8. Sorry. Yeah, Shift Alt 8. Cool. All right. Okay, so number 2. Shift Alt 8. Number 2. 110. Why? Because they are right next to each other. So if they're right next to each other, they're supplementary. If you were asked to prove that, how would you prove it? Just a what if, So it's because these two are parallel. So this is your transversal. So that means same side interior angles are supplementary. Isn't that nice? So you now see all those things we studied about parallel lines helping us in quadrilaterals, right? That's so cool. Okay, 3. 3. 100. Very good. Very good, Ricky. Next, Shift Alt 8. Right? Okay, next. Number 4. Number 4. They should be equal to each other because they're across each other. Perfect. It doesn't work for me? Oh, I haven't tried. Maybe I should try if it works here. 110. Shift Alt 8. Oh, it doesn't work for me either. Maybe I'm doing it wrong. Okay. Alright. Let's move on. Ooh, number 5. Number 5. Yes, 23. We should have a Kahoot on this next time. I know, right? I'm pretty sure this has a lot of Kahoot related stuff. So are we meeting on Monday or what? Is it even on Monday? I don't even know. Did you look in the St. Peter website? Yes? Okay, so alright. We're gonna do Kahoot on Monday. What are we now? Number 6. What's your number 6? 12.6. That's great. Okay, here we go. 7. Number 7. So RT is 19.8. You gotta find RP. RP, what are you gonna do? You gotta double. Very good, because they bisect each other, so that's actually half. Perfect. Number 8. Ooh. Ooh, be careful with this one. Look, look, look. It's just this little angle over here, okay? Uh-huh. What is it? Number 8. Don't look at the answers. As if you're looking at it. Maybe you are. Okay. Number 8. 38. 120. Okay. I can see where your 120 is coming from, Ricky. This whole thing. Oh, darn. Okay, this whole thing has to be 120 because it's next to 160. But you have to take away the 100, I mean the 52 right here. Okay. Yeah. 68? Isn't that too much? Oh wait, 120. Oh yeah. You're right. I was wrong. I was doing it wrong. My bad. Yeah, it's 68. Uh-huh. So 120 minus 52. Yeah. I know, like I told you to like subtract one from the other, and then in my head I was adding it. I was like, duh. Okay. All right. Dun dun dun. Next. What's next? Oh, number 9. 23.4 for km. So you gotta split by 2. Yeah. Okay. Nice. Next. Number 10. Number 10. You're gonna do the same trick we did in number 8. You subtract this from 180, and then after that, you're going to subtract 62 from the initial answer. So what is it? Yes. Uh-huh. So you gotta do 180, take away 55, and then whatever that is, that's the sum of these angle. And then after that, you take away 62. Yes. So this is 125, right? Now you have to subtract 62 from 125. Okay, yeah, 63. All right. Okay, clear that one. Here we go. Next. Now I have to solve. So this one, they are consecutive, so they're right next to each other, so you have to add them up, right? And then you gotta make it equal to 180. Okay? Go figure. And you're gonna do the same thing here. You have to add them up, right? Uh-huh. Because they're right next to each other, and then after that, you're gonna make it equal to 180. Okay, so how do you know again? How do you know again why? Well, you can make this equal to 100 if you want. Yeah. Okay, but I'm just writing the equation in a way that it works for all consecutive angles because I don't want to say this equals to 100. I don't want students thinking that, oh, you always make it equal to 100 because sometimes this is not 80. You get what I mean? Yeah. Okay. Next, you add these two together and then you make it equal to 180. Um and then get the x by itself. So when do you make it equal to 180 and when do you make them equal to each other? If they are opposites, they're equal. If they're consecutive, meaning they're side by side or right next to each other, they're equal to 180. Okay, these ones are for the sides, so they're opposite. So that means you're going to make them equal to each other. Okay? All right. Which one is 0? For number 13? Which one is 0? Number 12. Okay, that's fine. That will still make them equal to each other, right? Because if x is 0, yeah, okay. As long as they end up to be congruent to each other. What am I doing? Okay, so where's the chat? I don't know. We are doing this, honey, in case. There you go. So we are in this website right here. We're just practicing the computational part. All right. Now this one, they're right next to each other again, so you have to make them equal to 180. Okay? All right, we'll keep doing that. And while you're doing that, I need to check if you guys signed in. Because sometimes, okay, all right. I don't want to like run out of time. Because then it's gonna be like a problem for me. Just Andrea, Rudy, Chris. Guys, next time, if you can access this, please do it for me. I mean, if I gotta do it for like 1 or 2, it's okay. But if I gotta do it for everybody, that's not fun. Okay. Carter, I don't remember. Mishka messaged me via Remind. Nicholas, okay, Nicholas here. Maria is here. Marcelo is here. Okay, did I miss anybody? Okay. Giselle. I know, like, I do understand, like, my internet for the past few days. Oh, Madeline is here, of course. Yeah, it's crazy. Are you guys AT&T subscriber? Has your internet been crazy this week? Mine is at its worst this week for some reason. Okay. Alright, so for your homework, some of you have not finished the 2 progress checks in Schoology, so you have to finish that. And please mark off your calendar. All things for this grading period will be due March 5th. Okay? March 5th. No Delta Math. Yeah. But if you can practice on this website that I shared with you, that will be great. Okay? Especially the computations part. I forgot to show. Oh. Okay, I have to unsubmit that for you, Rudy. Give me 1 second. I have to pause because the grades may be showing. Hang on. No, but we're gonna do proving next time. Yes, on Delta Math. So Rudy, how do I submit this one? Unsubmit. Okay, so make sure you do. Here you go. Unsubmit. Okay, why is it late? Oh, I know why. It's a due date, huh? It was like, yeah, today's the 19th. My bad. Okay. All right. So, do you guys have any questions? If not, I will see you on Monday. We're gonna play Kahoot on Monday for a couple of minutes. Hi James. Oh, I have a mentoring today though. Yeah. I will meet with 2 math teachers today from San Pedro via Zoom. Yeah, that's why my Fridays don't have office hours. I'm so sorry, honey, but text me if you need help or anything, and then when I'm done, I'll text back. Yeah? My meeting normally lasts for an hour. Yeah. Okay. Thank you. I'm sorry I can't stay after class today. Extra credit for Kahoot, please. I'll think about it. Ooh, that's cool. Next, can you do it Monday? So for those of us who don't have nanotech and see it too. Okay. Extra credit, Chris. You wash your clothes at home and tell your mom to text me once you're done. That's extra credit. Oh my gosh.